Okay, so we're starting on a typical remodel or new construction. We're going to be doing the electrical work. We've got the roofing on, we've got the siding on, the building is rain tight. You really can't do any electrical work until you have all your siding on and you're rain tight. The inspectors of your area generally won't allow it. The first thing we're going to be doing is we're going to start setting our boxes. We're going to be setting them around the building. We may get the homeowner's approval before we nail the boxes down. In this particular case, we're going to start by putting a box here that's capable of using 2 switches. A single switch box would be considered 1 gang, a 2 switch box would be considered a 2 gang, and on 3 gang, 4 gang, depending on how many switches or plugs you're going to put in a location. In this case here, we have a couple of choices. We could put the switches right here, we could put them on the other side of the door, or we could put them here out of the way because the doors are going to swing open and are actually going to block the switches. In this particular situation, the homeowner wants the switches by the door, wants them on this side because there's going to be a fireplace on the other side. So let's take a look at some of the boxes that we have. These type of boxes here are an adjust-a-box. They're one of my favorite in remodel, where the level of the material that we're going to use on top of the studs is variable. Particularly if you're going to use paneling or you're going to use any type of tile, kitchens, bathrooms. These are really nice. They're really strong, they're secure, they're easy to move around. I've got the 2 gang box here that I want to use for the switch. I've got a single gang box here that I'm going to use in a future situation. In this particular situation where this box is going, I could use what's called a nail-it box, but it's going to be really hard to swing your hammer inside this little stud bay and put this up. So the first thing we need to do is go ahead and mark our heights for our switches. Typically, I like to go about 44 inches to the top of the box. That'll put it about 42 inches to center. You might want to check, with your inspector and make sure that this is the height that's acceptable for the area that you're in. So, box is going to go right here. I noticed that there's a little bit of crookedness to this beam here, and I'm going to try and set my box so that I don't have a problem with that. In this case, the adjust-a-box has a couple little hooks on it here to set onto the stud. I'm thinking of removing those so that I can adjust the box a little bit further to compensate for the crookedness. So I'm just bending these hooks off a little bit. This is what we call reality installation. This isn't just your typical walk up to a pre-framed stud for TV type show. This is how it's really going to be when you're actually working. So this box is going to fit really well and really easily in here. So this particular homeowner has asked us to go ahead and set the boxes at 52 inches up. You could put your boxes pretty much wherever you want them, but you want to be consistent throughout your house. So what we did was went back through the house, took a look at the heights of his switches, and we're going to go 52 to the top of the box. So again, you're going to have to make that decision with your architect, your designer, and also the inspector in your area. So I've got my marks, 52 to the top. I have, as you can see, I've bent the little hooks out on the box here so that I can adjust the box even a little further. I need to tip it a little bit so that I'm in plane with this surface right here. We're going to install these using sheetrock screws. It's really easy. If we've got to move something, I can get tight into the box here to nail down these ears. This box is going to be really secure even in a tight area. Basically, I'm just kind of looking down the plane of the wall because I like the box to be relatively straight. Some people don't care. I care. If you take the time now to get the box straight, when you go to do your sheetrock, it's going to be a lot easier. When you stand back and you look at your switch and it's crooked and you wonder why, it's because you didn't take the time to do it the right way now. All right, that box is pretty square, and it doesn't really matter what materials we use in terms of the depth right here, because we can adjust this down to, we can adjust it down to any depth we want, 1/8 inch, 1/2 inch, 3/4 of an inch. Right now I've got it set for 5/8. The next box we need to set is a single gang outlet box. Switch box, outlet box, really the same thing. You can put a switch or a plug in the box of your choice. This particular box is a nail-it box. As you can see, you're going to put it up to the stud, and you're just going to go ahead and nail it into position. It doesn't give you as much adjustment, or we do have the single gang adjust-a-box, which gives great adjustment. So just kind of have to make a decision what we're going to do right now. Typically, a box is going to go about 16 inches to the top of the box. Again, you might want to check with the inspector in your area, and you also might want to take a look at what they are around the rest of the building. If you've got odd heights around the rest of the building and you just pick 16 to the top, you'll be pretty good. So we've got a wall space here. It's more than 18 inches. Basically, it requires an outlet. So there we have 16 to the top. Another little trick you can use if you want that we used to do is we would just use our hammer height. So you'll notice here, if I just set my hammer on the floor, set my box on top of it, it's going to be pretty close. In this case here, it would be about 17 to the top. But depending on what you have for a floor surface, if you have 5/8 carpet pad, another 1/2 inch with a carpet, you're going to be raising it up an inch, in which case this would be great. The only problem is every different electrician's hammer may be a slightly different height. You may get outlet heights slightly different. In this case, it would work perfectly just to go ahead and use hammer height. It's going to give about a 1 inch for any type of material that they put on the floor. I'm going to move this back to the little stubs. They've got these little knobs right on the side of the box right here. And those little knobs are set for 1/2 inch sheetrock. So if you just go ahead and set it at those, that would be what 1/2 inch is. And those nubs are set at about 3/8 of an inch. You're allowed to have the box back up to 1/8 of an inch. I don't like to do that myself because then it winds up being too far back. If the box is crooked, if the sheetrock stands out from the stud a little bit, I would really prefer getting my boxes as close to the level of the sheetrock that's actually going to go on there. I happen to know this is going to be 5/8 sheetrock, so I'm going to set this box for 5/8 rock. Plaster veneer walls in this case. So I'm not going to use this nail-it box because in this case here, there's just going to be too much adjustment. It'll be a lot safer, a lot better if we go ahead and use the adjust-a-box. That way, if they go 1/8 of an inch veneer, 1/4 of an inch veneer, if this particular spot's a little higher or lower, they can adjust the box to whatever level they want. But I am going to increase my height a little bit to go for flooring. I'm going to go to 17 inches to the top of the box, and that'll give us 1 inch for flooring. All right, that one's done. And just to show you how it adjusts, basically all you got to do is adjust the box in or out to whatever depth that you want. If the sheetrockers, when they're doing their work, if they want, they can even adjust the boxes flush back, and it'll make them easier for them to get their sheetrock cut and lined up. One thing they got to be careful about is lots of times the sheetrockers are using roto-zips, and basically it's a method of cutting around the box. They're actually supposed to cut around the outside of the box with their roto-zip. They put the sheetrock up, cut around the box. What they do is they start in the middle and they find the edge of the box blind, and they wind up cutting our wires inside. So when you're detailing your boxes, you might want to shove your wires as far back to the back as you can in case you have someone that's not particularly skilled doing your sheetrock for you. Okay, so we're going to be moving around the wall over to the area where the controls for the TV are going to be. We're going to have a little closet here that's going to have VCR, DVD, CD player, pretty much everything's going to be in here. We're also going to have a little hidden switch right around the corner here that we're going to control our low voltage lighting. So we're going to have low voltage lighting out in the view out there. We're going to have probably some 50-watt up lights in our trees, some 20-watt low volt lights around the perimeters and in various areas. So we do want to set up for it. We're going to put a switch back in this section here, as well as some outlets for power. Probably going to put a quad box back here, a quad receptacle box you would use like a 2-gang. So we could have a duplex receptacle and a duplex. There's a lot of stuff to plug in back here. We want to make sure they've got plenty of outlets to plug into. So next thing we're going to do, we're going to go ahead and put our switch at the same switch height. "52" as far as our quad box, let's see, probably in this case, I believe that it's been set up so that the DVD player, CD player, etc. are going to be probably about 36 inches and up. So we're going to go ahead and set our quad box at about 44 inches. And I think the lower part of this cabinet, there's probably going to be more storage for CDs, probably some pull-out drawers, things like that. So I'm going to go ahead and set another mark back here at 44 inches. Looks like we're going to have to send out for some more 2-gang boxes. We've got a nail-up box here, which I'm going to go ahead and use. Maybe we're not going to use it. You know, we've got a problem here. This is really where these adjust-a-boxes really come in handy. I could go ahead and set this box, but we don't know what this cabinet's actually going to be. We don't know what the depth of the cabinet's going to be. We don't know how far it's going to slide back in. There's an awful lot of variables here. So I think we're going to have to go ahead and pick up some more of these adjust-a-boxes. So again, love these adjust-a-boxes. They just do a wonderful, wonderful job. They are a little more expensive. If you're installing hundreds of boxes, it will cost you a little bit more. Okay, another box ready to go. We got to do that single gang box over here. So single gang, another single gang adjust-a-box. Again, this is going to be the switch for the It's going to be the hidden switch for the outdoor low voltage lighting. It's interesting, the grain of some of these studs is causing my screws to dart off to one side or the other, so it's taking a little finessing here. So much hassle just to get a screw in. Okay, another adjust-a-box. We are going to keep moving around the wall this way. Basically, your receptacles, you need to be able to plug in a 6-foot cord anywhere in this room. A 6-foot cord's got to be able to plug in. Starting from a doorway, I believe it's about 2.5 feet from a door that you've got to start. You're going to want to check your local codes on that. So we've got an outlet here in this small wall. We've got a cabinet. We're going to go ahead and measure from this outlet to the wall. I've got about 36 inches, so 3 feet. So that means I could put my next outlet down the wall at 9 feet. So if we can have a maximum of 12 feet between the outlets, then 3 feet from that outlet to the wall, that would give us 9 feet this way that we could go. 9 feet is right about here. Now, according to the homeowner's drawings, they're going to have their bed on this side, and it probably would be much nicer to have a receptacle on the side of the bed on each side. So I think what we need to do is probably take a little look at the drawings, see where the bed's going to go, and probably put an outlet more probably down here at about the 5 foot, and then put another outlet probably at about the 12 foot or so that we can get on either side of the bed. So we're going to take a little look at the plans and see where that bed actually is going to be, and then we'll go ahead and set these outlets. So we've taken a look at the plans. We know exactly what we want. We know where the bed's going to go. In this case, it's going to be an Eastern King. It's about 82 inches wide, basically about 8 feet. It's going to center up in this room pretty much, and it just so happens that the plywood on the floor marks out the spot, starting from right about here. We're going to have nightstands. Nightstands vary in width, probably from 18 inches square to about 24 inches square. So I think we're going to back off from where we consider the edge of the bed to be. We don't want the movement of the bed while they're making the bed to knock their plugs out or damage the plugs or cause any types of fires. Fires, this is an interesting thing. In bedrooms now, the code requires that you use an AFCI breaker. AFCI is arc fault circuit interrupter. It is required. It is mandatory in most states for all of your lighting and all of your plugs in any new construction. These are really top-notch circuit breakers that will shut off long before any extension cord or any small fine wires will catch fire. So just keep that in mind. Remember, AFCI arc fault circuit interrupter. You're gonna require it. So we know we're gonna be putting our outlets right here. We know that our top of box is gonna be 17 inches. And did we figure out whether hammer height was exactly right or not? I think I went through that before. In this case, it's pretty close. So we got 17 inches to the top of the box. We are using adjust-a-boxes in this project because we're using 5/8 sheetrock and we are using a veneer plaster. So our heights are not exact. You know, while we're doing this, I would like to demonstrate something to you, just in terms of speed. These regular nail-it boxes, I mean, once you've determined your height and your depth, you know, you really can install them quickly. I mean, that has a certain amount of speed to it that I really like. I can see here that the nails drifted and it caused the box to be out an additional, let's see, what is it? It's about an eighth of an inch more on the bottom than on the top. And just looking at the box, I can see it's a little bit crooked. It's okay. It's a good, fast way to do it when you know exactly what the depth of your sheetrock is going to be. In this case, for a room this size, we're going to wind up saving a lot of time in the long run just by going ahead and using the adjust-a-boxes. Okay, all right, so we're going to go ahead and place this box on this. We're not even going to bother measuring it out. Apparently, we had some damage here. A couple of studs removed. I think the carpenters probably made a mistake or something like that. I don't really know what happened. But anyway, they're not here. I heard some noise about them having to get some big door in here. I don't know, the door's over there, it's not over here, so who knows what really happened. But anyway, this is going to be a good location. It's going to be about halfway on this wall here. The outlet on the side of the bed is going to be covered up with a nightstand. This is going to give a nice convenient outlet for the room in order to plug miscellaneous things in, vacuum cleaners, maybe a cell phone charger, whatever it is that you may have on this wall over here. Plus, of course, it's required by code. We've got to have one within about 2.5 feet of the door. Looks like we're going to be stretching that a little bit. And what we're probably going to do is leave the wires a little bit long on this in case we do decide to move it over a stud or so. But that's no problem. We're going to go ahead and mount this one now, 17 inches to the top of the box. Now, just for your information, one of the features of this drill bit that I haven't been using is there is a shield that I can actually pull over the screw. This keeps the screw from falling off the bit while I'm going ahead and putting it in. So I'm going to go ahead and use that this time just as an example. These particular sheetrock screws really seem to fit the bit very well, so I haven't really been having any type of trouble with the screws coming off, but it certainly is an advantage at some times. All right, so pretty much we have completed the receptacles and switches for this side of the room. We're going to go back and we're going to start drilling holes and pulling wire. So we've got a situation where we need to switch the lighting in this room, and we are ultimately going to have recessed lighting. We have flexibility. We don't have to do things exactly the way the plans are, and right now I'm a little bit concerned about putting the switches on this side. It just seems a little bit far in with this structural beam here. It seems a little far in for me, so I'm trying to work out where I think that the switches really ought to be. Basically, this is going to be the entryway to the room, but the entryway to this part of the building is slightly off to my left here. So it might actually work well as a possibility to have the switches on the outside. It's something to consider anyway. Or on this side of the room. They'll be a little bit closer to the doorway here. I could reach in and switch them. So I think what we're going to do is we're going to take a couple of minutes, we're going to talk to the homeowner, and we'll come back with a final decision. Okay, so we've talked with the homeowner, and the homeowner has told us that the door is actually going to be opening this way. And that really only leaves us one place that we can put the switches, which is going to be over here on this beam. I had thought about putting it out on the outside here, but we're going to need to locate it on the inside because it's going to be the only switch that actually controls the lights in the ceiling. Sweet. Okay, so we've set all our boxes on this side of the room here. Again, you're going to have to imagine that these studs are back in here. They are going to go back in now that we got our large door in. We're going to go ahead and start drilling out for our boxes. We're going to start detailing. When we've got these drilled out, the wire pulled and detailed, then we're going to go back and we're going to start on our ceiling lights, on our recessed cans. And the recessed cans are going to be really fun. It'll be a really interesting project. Okay, well this is a fairly small project, and we can decide a lot of the things we want to do. We can decide whether we're going to use adjust-a-boxes, nail-it boxes. We can also decide how many circuits that we want to use in this room. From a code point of view, actually one 15-amp circuit could be used for all of the plugs and all of the lighting. But in this circumstance here, we may want to add a couple of circuits. I mean, arc fault breakers are about $50 a breaker. So if you use one, it's 50 bucks. If you use two, it's 100 bucks. $50 can buy, you know, a whole bunch of fancy switches, another light fixture, a lot of things. So we have to consider, you know, what we're going to do in this particular case. Here, we're going to have about 10 receptacles. We're going to have 4 to 6 recessed cans. We're going to have a fireplace. It's going to be a gas fireplace with an electric blower, and we're also going to have an entertainment system. So I think would probably really like to go possibly with a couple of circuits. The other item that we have, of course, is the fireplace. The fireplace, since it does have an electric motor, you might want to check with the codes in your area, is going to require a dedicated circuit for that particular apparatus in order to be code. So it looks like we probably ought to use at least 3 circuits for this area, which seems a little overkill, but we have the option to do that, and that's what we're going to do. We're going to have our audio-visual, our media center on one circuit so we can run all of that equipment. If someone blows a breaker, maybe we have a short in a lamp or an iron or something that someone's using here, or they bring in an electric heater temporarily, we won't trip a breaker that our media center is on. So I think that's going to be a really good planning on our part. What we need to do now is know that our main panel is going to be down on the outside of the building in this direction. So all of our circuits are going to be going that way. What I need to consider now is which way our home runs are going to be coming in. In other words, how we're going to wire our circuits. We probably need to put in a large enough hole as we drill across here to have the circuit for the plugs on this side. We need to have the circuit for the entertainment center, and we need to have the circuit for the fireplace, which is going to be in the far corner over there. So I'm going to choose an appropriate size bit that I can drill this with, and we're going to go ahead and get the drill set for installing our wires with. Okay, so the next part of the process is to start pulling wires. We've pretty much determined how many circuits we're going to run. We're going to run 3. One for the fireplace, one for the media, and the other one to run pretty much everything else. Exactly how we're going to run those circuits is a good question. I haven't laid that out yet, so we're going to take a little look around the room and see. We've got a pretty tough corner over here to go through. So getting around this corner it's not like we're going to, well, we could hack up their beams and drill around it, but I'd really rather not do that. So I think what we're going to do is we've got a few things to consider. We've got to consider where we're bringing our circuits in. We know we're bringing them in from that direction. And we've got to consider where we're going to be junctioning and which directions we're going to run our wires from, since a box, as a matter of fact, that's something that I definitely need to tell you about, is these boxes are marked inside, and I don't know that you can see it. You may be able to, I'm not sure. Inside that box, on this side over here, are some numbers. And it tells you how many 14 gauge wires, 12 gauge wires, and 10 gauge wires you can fit in these boxes. Anyway, we have to consider that because we can only junction so many wires in there. So, how many wires can we put in there? This will take 8 10s, 9 12s, and 10 14s. Wires are counted, and you might again want to check in your jurisdiction, but according to the National Electric Code, you've got to count every wire that comes in there. So if you have a Romex that has a hot, a ground, and a neutral, that's going to count as 3 wires. The ground, no matter how many wires you run into here, counts as 1. So if we run 3 14-2s into here, we're going to have 7 wires. That's going to be 3 hots, 3 neutrals, and 1 ground. Then the device, whatever you put in here, a device counts for 2 wires also in terms of fill. So we're already up to 7, we're already up to 9, a count of 9 just by having 3 wires coming in here and 1 switch or receptacle. So since it only allows 10 14s, we're already at our max. We've got to make sure that we don't try and run more than 3 wires into any one of these smaller junction boxes. And these are a little bit deeper, these adjuster boxes are a little bit deeper and will take a larger number of wires. But something you got to consider, a lot of inspectors, you know, they may call you on this, they may not. Physically, what you've got to do is make sure you got enough room so you physically can do this. And I would strongly recommend that you follow the count that they allow, because it's a matter of heat and it's a matter of safety. So it looks like what we're going to do is we're going to go ahead and set up our drill. I use a pretty heavy duty drill. Got to be careful with these. I've had one of these a little bit too close to my chin, and they will make you see stars. They will flat knock you out. So you really got to be careful with one of these drills. Basically, this has a high and a low gear. So when you're drilling a lot of holes, you can get a lot of speed out of it. It's very powerful. It's really strong. As I said, you hit something, you hit a knot or something with this, and it has the potential to cause you some damage. So you really do need to be careful. I just happened to bring, I think, some relatively new drill bits. So if we don't hit any nails with these, we're going to be able to move along pretty quickly. Here's a question for you. This is for both contractors and homeowners. First of all, do you know what a Jacobs chuck is? This is a Jacobs chuck. It's kind of like, this is a Phillips screwdriver, this is a Jacobs chuck. A Jacobs chuck has 3 holes in it. 1, 2, 3. What are those 3 holes for? Those 3 holes are to tighten whatever you put into it, whatever bit you put into it. And they're there, all 3 of them are there because you're supposed to use all 3 of them. You tighten in that one. You go to this one, you tighten in that one, and then you tighten in that one. And the reason is that the bit itself will kind of torque up. And when you hit all 3 of them, you're actually going to tighten the bit all the way so that it doesn't fall out on you. A lot of guys don't do that. They just tighten on one, they're drilling away, and pew, they'll lose their bit down a wall, it'll fall off, they'll cause some damage to the bit. So use all three of them when you're tightening up. Also make sure that when you're tightening your bit, your plug is not plugged in anywhere, because if you have this in place and you hit the switch by accident, this could spin around, catch your hand, could cause some serious damage. You can also use a more higher powered battery drill. The thing is, you're just not going to be able to drill that many holes. If you need to drill 1 or 2 holes, this does chuck up a 1/2 inch, and I could actually could chuck this up. And I actually could drill a hole with it, probably on low, on high torque. It's just that it's gonna drain your batteries pretty quickly, and you're not gonna be able to drill a whole room full of holes with this. I mean, if you got enough batteries and you got enough time, yeah, you could do it. If this is what you have available and you have time, then you could go ahead and do that. But it's definitely going to take you a while. And also, you notice this is a much smaller bit. Well, it's not much smaller, but it's somewhat smaller in diameter, and that's going to make a difference in how much battery power or how many wires you can pull through. I wanted to pull a few extra wires through, so I was going to use the larger bit. But I'll go ahead and leave this chucked up in case I want to just do a spot drill here or there. I may go ahead and use that one.
Home Improvement Camp. Have at it.